Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on aside as we jump into the Chapter 7 test and cumulative assessment in the Big Ideas Math Integrated Math 3 textbook on everything sequences and series. Now, as the name says, it is a test, if you will, so we're going to test your knowledge and see how you do in comparison to this video. Less teaching, more doing in this setup. We'll see if this goes relatively quickly or not, all depending on the calculations I have to do, stuff like that. Maybe I struggle through the problems myself. We'll see. Jump to the description section down below if you'd like to find either PDF of the test or cumulative assessment, as well as the timestamps and playlists for anything else from this chapter previously. Without further ado, let's go ahead and get started. We are going to begin with numbers 1 through 4, where they ask you to find the sum. Now, I couldn't tell you straight up which each section this would be derived from. Anything could be, ideally, from 7-1 to 7-4 from this setup here. The first one has terms 1 to 24 of 6i minus 13. Now, this is an arithmetic sequence with this in mind, so I'm going to use the arithmetic series sum formula. There are 24 terms involved. Let's find the sum of the first, let's find the sum of the first 24 terms by dividing 24 over 2 and multiplying by the first term plus the last term. Now the first term, a sub 1, would be 6 times 1 minus 13, which is negative 7. And the last term, a sub 24, would be 6 times 6 times 24 minus 13. 131. I gotta get the calculator out pretty quickly here, I'm sure. Which is 131. So this is going to be 12 times 124. 1480, 1488, 1488 would be that sum. Number 2, the sum of the first 16, the sum of the squares of the first 16 positive integers, 1 plus 2, 1 plus 4 plus 9, etc., all the way to 256, which is 16 squared. I'm having a lot of typos right now. Writing the wrong numbers and letters and things like that. Now, this one here for a quadratic set, specifically of just this kind, we can take the last term, n times n plus 1 times 2n plus 1. Let me actually, although it's less teaching, you need to know specifically what I'm putting in here. 2 times 16 plus 1 all over 6. This is going to very specific formulas. Again, this is out of section 7.1 that we would have done this one. So that's going to be 16 times 17 times 33 all over 6. Now, there's at some point I'm going to do some calculations, but 16 over 6 is also, 8 over 3. And 33 over 3 is 11 over 1. So 8 times 11 is 88. We have to do 17 times 88. Let me use the calculator for that. 17 times 88. 1496. So that's the sum of 1 plus 4 plus 9 plus 16, etc., all the way to 256. Number 3. We're doing a geometric series, and it is an infinite geometric series. Now, this sum does exist because the common ratio that we are looking at is 0.8, which is less than 1. So we will apply the formula. So a sub 1 is actually 2 is going to be your first term, and r is 0.8, which is less than 1, which is good, between negative 1 and 1. So we're going to do a divided by 1 minus r. 1 minus 0.8 is 0.2, and 2 over 0.2 is 10. 10 is the sum of this infinite series as you do 2 plus 80% of 2, which is 1.6, plus 80% of 1.6, etc. Infinitely, it converges toward the value 10. Number 4 is also a geometric series. It is finite. It does have a negative common ratio. Your first term is 4. Now, that number in front is not always your first term. It just so happens to be in this case because it's raised to the I minus 1 power. If I do substitute 1 in here, I will get 4 out. So this is, again, your first term, and this is your common ratio. Now, this one for a finite series, you take your first term times 1 minus your common ratio to the nth power. You're going from 1 to 6, that is 6 terms, all over that 1 minus r here. Now, 1 plus negative 3 is 4. So this becomes 4 over 4, which is 1 right there. And you're just left with this 1 minus, and 3 to the 6th might be 729. I think it's 729. So ultimately, you just have 1 minus 729, which is negative 728. Doesn't make sense we have a negative answer. What's actually going on here when we compute these things? The first term is 4, then times negative 3, then times negative 3, times negative 3, times negative 3, times negative 3, 972. You're computing all of these together and you get negative 728. Does it make sense the number's negative? Yes, it does, because the last number we subtracted was negative and it's the biggest of them all. After swinging positive to negative, etc. So it does make sense that we actually get there. To me, I believe in the answer, and the formula seemed to work out. Now, one thing I do want to keep in mind is that this one did become 1 plus 3 because we subtracted the negative. This does not become 1 plus 3 to the 6th. So why does 1 become 1 and 1 not become the other? Because PEMDAS. We have to do negative 3 to the 6th power first and then subtract that result. And negative 3 to the 6th is a positive number. It's positive 729. And that's what we get. Okay, numbers 5 through 7, we have to determine whether the sequence is arithmetic, geometric, or neither. Explain, and then write the rule for the nth term. Now, an arithmetic sequence will appear linear. A geometric sequence will appear exponential. To me, I'll go based off appearance alone. We can look at the numbers after to write the sequence. If it doesn't appear to be either, then it will be neither. Now, I'm going to write out the list as it is. 1, 1, 2, 2, 3, 4, 4, 8. I'm looking at the y values, if you will, or the a sub n's. This is a geometric sequence, not just by the common ratio, which I'm noticing is a times 2. But if you look at the graph as well, it did appear exponential. It is geometric, and writing the rule for the nth term, we need the first term times the common ratio to the n minus 1 power. This can also be written more simply as 2 to the n minus 1 power. My writing right now is just terrible. I don't know if I'm trying to rush something, if it's hard to talk while writing. I don't know what it is, but it's just terrible. It is a geometric sequence, by the way. Number 6. 6 appears arithmetic in that the points appear linear. We'll see if they indeed have a common difference. So the first term's 11, second term's 9, third term's 7, fourth term is 5, and so on. Yes, it appears to have a common difference of negative 2. We're subtracting 2 or adding negative 2 from one term to the next. So an arithmetic sequence it is, and an arithmetic sequence has such a rule, such we take your first term, add your common difference times n minus 1. Negative 2n plus 2 comes out when you distribute that, and 11 plus 2 is 13. So you get negative 2n plus 13. By the way, it said explain your reasoning for your things here. I'm showing my reasoning on these two. Times 2 each time, minus 2 each time. Although I did also state out loud the first one appears exponential, second one appears linear. And that's what they would be. Number 7 does not appear to be either. It has... might be logarithmic, I don't know, but 1/4, 5/12. Well, it may be exponential. If it's exponential, geometric, then it has a shift and it's asymptote. I don't believe that's what this is. 1/2 and 13 over 24. Very, very interesting. What's going on here? I'm going to say I don't know off the top of my head if it's geometric. It's definitely not arithmetic because the points aren't linear. What I would check for geometric is what is 5/12 divided by 1/4, or 5/12 times 4. That's 5/3. So we're multiplying by 5/3 here. And what is 1/2 divided by 5/12? It's 1/2 times 12/5, which is 6/5, which is not the same thing. So this is a neither case. I'm showing that it does not have a common ratio. So it's neither. Doesn't mean there's not an equation. It kind of looks like there might be a pattern, but we have to figure it out. And I almost want to figure it out in a way. I'm having trouble because what I want to think about is I want to kind of get a common denominator. Maybe that'll help, but I don't actually know. Let's see. Let's get a common denominator. Multiply this by 6 over 6 to get 6 over 24. Multiply this by 2 over 2 to get 10 over 24. Multiply this by 12 over 12 to get 12 over 24. And that's 13 over 24. Do we see a... oh. plus 4 plus 2 plus 1 on top. It's shrinking. I don't know if I can come up with something for you on here, unfortunately. Can't see what I'm multiplying by each time, so I want to say that I'm adding something that's different each time as I go. By the way, it's not truly plus 4, right? This is plus 4 over 24. So adding 4 over 24, adding 2 over 24, adding 1 over 24. That's shrinking as we go. How about if I reduce these now? This is plus 1/6 plus 1/12 and plus 1 over 24. If we could find a way to explain that we're just adding 1 on top and the bottom's increasing by a certain amount because it's doubling its previous set, that might help. This is kind of tough. Are we supposed to be writing the rule even if it's not? Oh, I didn't even move this to 7. I apologize. Are we even writing a rule? Write a rule for the nth term. Yeah, even if it's not that. So let's go off that there. It's not a common difference, but it's adding something that seems to show a pattern. So the second term takes... I'm going to go off the previous term. They didn't say write an explicit rule. It takes the first term and it adds 1/6. The third term takes the second term and adds 1/12. The fourth term takes the third term and adds 1/24. Now, 1/6, how can I use the number 1 or 2? How about 2? How can I use the number 2 to get 6 and use 3 to get 12 and 4 to get 24? Oh, I just had it in my head. I would do... 12, hold on. 2 to... Oh, I just had it in my head. 3 times 2 is 6. This is 3 times 2. This was 3 times 4 and 3 times 6. That means that the 3 can stay consistent. 2 is increasing by 1 each time. I'm sorry. I had something in my head. Now I completely lost it. 1/6, 1/12. I'm sorry. That's not 1 over 24. Maybe that's why I lost it. This should be an 8. There we go. Now I had it. I had it before and I lost it when I saw that. So this is 3 times 2 to the first power. This is 3 times 2 squared, and this is 3 times 2 cubed. Aha! So I have some version of something I can write. That means a sub n can be a sub n minus 1, like I'm looking at the 4 and the 3, plus 1 over 3 times 2 to the, if that's a 3, that's a 3. That'd be n minus 1 power like that. So that's a rule. I don't know if that's the one they would have wanted or whatever, but that is a rule that works out for that thing. I'm going to go ahead and use that. It seems to align with the first few. Oh, and I need to say what the first term is as well. The first term is 1/4. So a sub 1 is 1/4. And then that, if I'm going to do a recursive rule, I have to kind of state what the first term is going to be from that. Okay, that is number 7. That was kind of tricky. Gave me pause, and I don't know if that's the best way to have done it, but there we go. Write a recursive rule for the sequence, then find a sub 9. Now, I just did a recursive rule in the previous one. What's interesting, well, a couple things that are interesting. Number 1, the recursive rule requires that you write the first term. So a sub 1 is 32 is a part of what I'm going to write. And then r is 1/2 common ratio means you're multiplying 1/2 times the previous term that you have. So there's the rule. The other interesting part is they say find a sub 9, which normally that would mean substitute 9 in your equation. But they ask for recursive rule, not explicit rule. Explicit rule is the one where it's easiest to substitute 9 into here. Recursive rule, unless I do the explicit rule, which isn't too bad to do, I should just be doing 1/2 each time until I find a sub 9. So a sub 1 is 32. So here's the first term. Half of this is this one's second term. Third term, fourth term. Fifth term, sixth term. Half of 1 is 1/2. Half of a half is a quarter. That's the 8th term, so it's 1/8. This is a sub 9. So I'm using recursion to get the 9th term by going from one term to the next, etc. Kind of interesting that they asked for the recursive rule with that in mind. Number 9 is an explicit rule. So to find a sub 9, I could use the explicit rule for that. They did ask for the recursive rule, so let's do that. A sub 1 is 2 plus 7 times 1, which is 9. And A sub n is taking your first term, or excuse me, the previous term, and adding 7 to it. 7's the common difference in this case. That plus 7n being multiplied by n means that's how many times you add to it over and over, which means it's an arithmetic sequence. So you're doing an adding of 7 as opposed to anything else. Now, A sub 9, I'm going to use the explicit rule for that. You could start from 9 and add 7 a bunch of times, or you could do 2 plus 7 times 9. Let it work out that way and get 65. Number 10. Number 10 seems to go by its own rules, neither arithmetic nor geometric, based on what I'm seeing. What I'm seeing, maybe you're seeing the same thing, is we subtract 2, then 3, then 4, then 5. So it's one of those things where you might want to build up the pattern to begin with, like the second term takes the first term and then minus 2. The third term takes the second term and then minus 3. Fourth term takes the third term minus 4. Fifth term takes the fourth term minus 5. So clearly our A sub n rule, first of all, A sub 1 is 2. And our A sub n rule is going to be taking the previous term and then minus n. Because A sub 2 subtracts 2, A sub 3 subtracts 3. So minus n in this case. If this was an explicit rule they asked us to do, it would be a quadratic because the common difference has a constant difference. Excuse me. The second difference is constant. So it would have been a quadratic of some sort. They didn't ask for the explicit rule, so we're not doing that. They do want the ninth term, though. So the ninth term, we have the first 5 terms. The sixth term is minus 6, which is negative 18. The seventh term is minus 7, which is negative 25. The eighth term is minus 8, which is negative 33. The ninth term is minus 9, which is negative 42. Here is our A sub 9. Number 11. Write a recursive rule for the sequence below, then write an explicit rule for the sequence using your recursive rule. I'll write an explicit rule how I want to. Thank you very much. And I would like to use it with my recursive rule. Thank you for not giving me free will. It's that, you're fired, too late, I quit. No, yeah, I would probably use the recursive rule because you need the same two things. For the recursive rule for this, we need the first term, which is 5. This clearly, well, to me, clearly has a common ratio of times negative 4. Each time we're multiplying by negative 4. So it says to get the next term, take negative 4 times the previous term. There's the recursive rule. Now, both the recursive rule and the explicit rule require the first term and common ratio for a geometric sequence. So that's why we can use the recursive rule for it. That's why I want to do it. It's probably why the book requested that we do it. Here's the geometric sequences explicit rule. Is that all we had to do? Write the recursive rule, write an explicit rule for the sequence. Yes. So those are the two things we're going to do there. I always want to put that times there. Number 12. The numbers A, B, and C are the first 3 terms of an arithmetic sequence. Is B half of the sum of A and C? Explain your reasoning. I have to think about that. So A, B, C, they have a common difference. Let's call that common difference D. We're adding a common difference each time. So B is A plus D, C is B plus D, and C is also, if it's A plus 2D, right? You had the common difference there. Is B half the common difference? Is B half the sum of A and C? Excuse me. How can I work this out to be like, here, let's do this. I might not need this one. Let's go to these ones and get D by itself. D is B minus A, and D is C minus B. I actually probably should have written it this way first anyway. That's how you should come up with common differences. Do this minus that, this minus that. That means B minus A and C minus B are the same thing. Now, if I add B to both sides, if I add A to both sides, I get this. If I divide both sides by 2, or take half of it, how about multiply by 1/2? If I multiply this by 1/2 and multiply this by 1/2, then you get B equals 1/2 of A plus C. Whoops, that's a B. Another typo. What was the question? Is B half the sum of A plus the sum of A and C? Yes. Yes, it is. Now, that's without using any numbers and examples and things like that. That's just the idea behind it. Okay. But yeah. Number 13. Use the pattern of checkered board quilts shown. It looks like the number here is representing how many blue squares there are, if that's going to be a question. Yeah, what is N? Okay, what does N represent for each quilt? What does A sub N represent as part A? So, if you can't see this very well, I might have to do some drawing manipulation on this thing. N represents basically the number of like rows or columns there are, because it's a square with checkerboard base. So like N represents the numbers of the number of rows or columns there are in each. Do they call it a check? No, in each quilt. And A sub N represents the number of blue squares based on what I'm seeing. The number of blue squares there are in each quilt. There might be a different pattern, but so far that has agreed with it. But there might be other ones that agree with it. Part B, make a table that shows N and A sub N for N equals 1, 2, 3, 4, 5, 6, 7, 8. Now, I don't know if we're going to need the drawing for this or if we can recognize a pattern for ourselves. So, they actually want a table. We can't just write a list. So, for this one here, let's do N and A sub N. That's too thick. All right. Okay, we have 1, 2, 5, 8. Add 1, add 3, add 3. Didn't really have a pattern there. Times 2 times... What's the 5 going to have? Surely there must be a pattern somewhere. A 5 by 5. I have to draw it. I'm going to use, like, hold on. I don't know why I'm having trouble with this. I'm going to make a 5. Hey, where'd it go? Here it is. I'm using a 5 by 5 grid thing in just a moment once I figure out how to activate this. Select it and shrink it. Okay, it's not going to be squared off. I just need to see what this looks like personally. I need to figure out what this pattern is. So, all right, 3, 3, 3, 2, 2, 13. Oh, 5 plus 8 is 13, but that doesn't work for. Did I miss one? 1, 2, 5, 8. Seems like the odds, maybe the evens have their own separate pattern set and the odds have their own separate pattern set. Here, this might be like plus 4, plus 8, and that's plus 6. Maybe the next one's plus 10. Maybe the next one's 18. If the next one's 18, then I feel there's some pattern, but I don't know if I can really get a good version of that pattern. Let me try 6 by 6. Apologize if I'm missing it. If I'm completely missing what that pattern's supposed to be. There might be something there along the way. What do I suspect the next one's going to be? Plus 10, 18. So let's try that. This is 1, 2, 3, 4, 5, 6. Yeah, so this one's going to be 18. So I'm seeing a pattern within, but it's not really... I'm not seeing the connection from one to the next here. I'm looking at odds and evens separately so far. So from 1 to 5 was plus 4. From 2 to 8 was plus 6. From 5 to 13 was plus 8. From 8 to 18 was plus 10. From 13 to this one must be plus 12. And then from... Oh, plus 12. What's that? 25. And then from this one to this one must be... Whoops. Must be plus 14. So 32. Okay. Plus 1, plus 3, plus 3, plus 5, plus 5, plus 7, plus... Oh, okay. I take it back. There's still something there as well. You're adding 1 twice and 3 twice. You know what? I didn't see that either. Only because the first one didn't work with it, but we're also missing like a 0th term. A 0 could also have 0, and then you could have +1. So add 1 twice, then we add 3 twice, then we add 5 twice, then we add 7 twice. I'll take that for what it is then. That's fine. So, okay, make a table. Oh, we did. Part C, use the rule to find a sub n for these. Compare these values to those in your table. What can you conclude? Explain. Yeah, I'm sure there are ways to write the rule out, and I don't know if I would have recognized this, but well, this is one of those problems that might take a while. Even for me, I'm just looking through it and I'm like, what do I do? Oh, I wanted to keep those zeros there. Okay, C. A sub n is n squared over 2 plus 1/4 times 1 minus -1 to the nth power. No, yeah, I wouldn't have come up with that rule myself, so I guess we got to do it for each one. A sub 1 is 1 squared over 2. Now I'm going to do this pretty quickly. Plus 1/4 times 1 plus 1. No, well, to the first power. 1 minus, yeah, so 1 plus 1 is 2. So that's 1/2 time plus 1/2, which is 1. A sub 2 is 2 squared over 2. So 4 over 2 is 2. Plus 1/4 of 1 minus. So each time here, what's going to happen basically is you're either going to add 1 or you're going to subtract 1. When it's an odd number, you're going to add 1 because 1 minus -1. When it's even, it's going to be a positive 1, and 1 minus 1 is 0. So this goes away, and this becomes 2. Is that right? That is right. So I think they're going to say, what do you notice? We're going to notice we get the same values, I think. A sub 3, 3 squared over 2, which is 9 halves. So we're going to do 9 halves plus 1/4 times 2 again. So either this is going to be adding 1/2 or adding 0. And this one adding 1/2 is 10 halves, which is 5. Next one is 16 over 2, which is 8, and then plus 0 is going to happen. Next one is, what I'd like is just noticing this pattern itself. 25 over 2 plus 1/2 is 26 halves, which is 13. A sub 6 is 36 over 2, which is 18, plus 0. A sub 7 is 49 halves, plus 1/2, which is 50 halves, which is 25. And A sub 8 is 64 halves, which is 32. So our list is going to be 1, 2, 5, 8, 13, 18, 25, 32. What do you notice? What do you know? They are the same. They are the same. Okay. Cool. Number 14. During a baseball season, a company pledges to donate $5,000 to charity plus $100 for each home run hit by the local team. Does the situation represent a sequence or a series? Explain your reasoning. If you're adding 100, wait. Well, I need to process this because the idea to me is they're going to do this, plus this, plus this, plus this, plus this, etc. Whoops, plus 100, plus 100. That's the way I'm interpreting this right now. I'm not interpreting it as this, plus this, plus this, plus this, plus this, etc. Keep adding an extra 0 at the end. Is it this one or this one? Now, if it's the first one, that means that you could write it out also as a sequence, as in first they've donated this much, then a home runs hit, now this much is donated, then a home runs hit, this much is donated, which to me then represents a sequence. But in this one here, you're adding another 5. This would be impressive if they were doing this and adding it that way, and that would therefore represent a series. I'm gonna think about that one. Give me 1 second. Okay. I mean, I thought about it. I'm still conflicted. Here's the thing. I don't think it's this situation. I don't think that they're doing 5,000 to start off with, and then they'll add 5,100 after the first home run, etc. They literally say $100 for each home run hit. So I feel like it's more of this thing here. But the question is, do you call this a sequence or series? I want to call it a sequence, in that you can represent by the number of home runs. So if I call it a sequence, we're actually looking at A sub n, the value of how much they donate based off n home runs hit would be 100n plus 5,000. So if they hit 32 home runs, it's $3,200 plus the 5,000, which is 8,200. And you can see it as a sequence there. That being said, we are adding hundreds each time, yeah, but that's what the sequence is also showing. Now, as a series, if this was a series, or if you wanted to write it as a series, you have an option of doing it like the initial 5,000 plus, and you can use sigma notation for the series for n equals 1 to, I equals 1. I equals 1 to n of 100. So you're adding 100 for each of these that this increases by. But I equals 1 needs to, well, I equals 0 to n. How about that? Because you might have 0 home runs hit. So, excuse me. Then I guess it would be 100. I'm missing something there then. The sum of... I'm trying to think if a 100 goes in the first time if I equals 0. It would, wouldn't it? No, if n is 0... Shoot. I'm having trouble. I don't want to call this a series. I don't want to call it a series. There's something along the lines of this that I could use as a series, but that's just weird. I don't like to build it into that. I feel like we haven't done too much on series yet, so they might have wanted to bring that up. I'm going to call it a sequence. I'm going to say it's a sequence based off this thing here, and that's what it can be. That's my go-to. That's my interpretation of the problem. Okay, number 15. The length, L sub 1 of the first loop of a spring is 16 inches. I guess that's what's in blue. I don't know if you can see that very well, but I think it turns green after that. The length L2 of the second loop is 0.9 times the length of the first loop, so 90% of it. It loses 10%. The length L3 of the third loop is 0.9 times the length of the second loop, and so on. Suppose the spring has infinitely many loops. Would its length be finite or infinite? Explain. Find the length of the spring if possible. It would be finite. Even if it went forever, eventually it would work its way toward 0, microscopically so toward 0, and it would converge toward a value. So it would be finite. Now the reason for this is because the values are shrinking towards 0. Your R value is 0.9, and 0.9 is less than 1. More so the absolute value of it is less than 1, but it's less than 1. They said find the length of the spring if possible. Well, it is possible. It's possible, and what you can do is you can find the sum, the infinite sum here, with the first a sub 1 being 16. You divide that by 1 minus 0.9. That's a sub 1 over 1 minus r, which is 16 over 0.1, which is 16 times 10, which is 160 inches? Inches. 160 inches of spring length, even with the infinite set. I know, right? Okay, let's go to, normally I zoom out and zoom back in. I didn't realize, I forgot I was on a chapter test thing. But guys, we're going to go straight to the cumulative assessment. I think 8 questions for these ones. Start with number 1. The frequencies in hertz of the notes on a piano form a geometric sequence. Same chapter 7. The frequencies of G, labeled 8, that is the G note, and A, labeled 10, that is the A, are shown in the diagram. So they said geometric sequence. So including the black keys. So it's like the 8th term, we can kind of see it like this. The 8th term is 392, and the 10th term is 440. What do they want? An equation for the sequence? What is the approximate frequency of E flat labeled 4? That is an E flat. Okay, so we want to find out what A sub 4 is. in order to do that, let's come up with the rule. Set up a system of equations. 10 minus 1 is 9. 8 minus 1 is 7. I'm going to use the elimination method and divide out. Now, this is going to be a little weird. 440 over 392 is not a pleasant number. It's not at all, in fact. Let's see if the square root's any better, because we got to take a square root. No, it's not pleasant. I'm just going to write 440 over 392. Actually, what I'm going to do is I'm going to reduce that fraction. Give me a moment. I'm doing this on my calculator. You can't see it. I'm just doing some fraction work. Oh, 55 over 49. So 440 over 392 is also 55 over 49. That's a little more pleasant, because if I take the square root of both sides, boom, I'll get r equals square root of 55 all over 7. So it's irrational. That's why the numbers weren't too pleasant. But as a fraction, it ain't too bad. Now, I'm not going to do the plus or minus because these frequencies can't be negative. I'm just going to use positive versions of it. Let's write out the, I still need a sub 1. So 392 equals a sub 1 times r, times r to the 7th power. Ooh, this isn't going to be good. Square root, hold on. I'm doing stuff on my calculator. Taking the square root, I now got to raise it to the 7th power. This is not going to be clean. And I'm going to divide 392 by that number that we're doing there. All of this is approximate anyway, so I'm just going to give you an approximation. My calculator says one thing that I'm getting as this 392 divided by that thing to the 7th power. So I'm going to round it to about just 262 for now, but I'm going to use my calculator to get the exact answers for you on here. So it's about 362, which is about, it's about that C right there on the first key. So here we're going to say a sub n equals 362 times root 55 over 7 to the n minus 1 power. So to find a sub 4, we're going to do 362. And again, I have a different number on my calculator. Times root 55 over 7 cubed. So, oh, I'm sorry, not 362, 262. I've been writing the wrong number. 262, 262, 262. Okay. 222. Okay. So, on my calculator, I have this 261 point whatever number. Let's do that times root 55 over 7 raised to the 3rd power. That's getting us about 311. This is the frequency of a sub 4, which is that E flat. So it's about 311 hertz. Is that one of the options? B. It's about B. Now, there are other ways we could have gone about that. We could have used the common ratio and divided from the 8th term to the 4th term 4 times. So divided by root 55 over 7 to the 4th power, that would have gotten us to the same answer. So we could have done 392. We could have done 392 divided by root 55 over 7 to the 4th power. And that should have given us, oh, did I divide? I did. Why did that go wrong? Root 55, excuse me. There we go. And that would have given us that same answer there. So, okay. Okay, let's move on. Number 2. Tricky, man. Cumulative assessments are not for the faint of heart. You take out a loan for $16,000 with an interest rate of 0.75% per month. At the end of each month, you make a payment of $300. Write a recursive rule for the balance a sub n, the loan at the beginning of the nth month. This was still in this chapter 7. So our a sub 1, they did say write a recursive rule, so this is a part of it. Our first term is $16,000, the loan that we take out. Now for our rule, we're doing 0.75%. So this is a monthly thing. So 0.75% interest is 0.0075. Because this would have been 1%, so 0.0. And we got to do 1 plus that. So 1 plus 0.0075 is 1.0075. Let me rewrite that completely. So we're multiplying our previous term by that amount, and then we are doing a monthly payment of $300 at the end of each month. So we got to take that out as well. That would be the recursive rule for this situation. Part B, how much do you owe at the beginning of the 18th month? This is something where they were doing a spreadsheet thing like this before, so I'm going to do a spreadsheet as well. Let me pop that up. Google Sheets. I'm going to do a Google Sheets thing of this. I wish I still had the previous one that I made. And I think based off of what they did at the time, I'm going to remember to zoom in for you guys. Based off what we did at the time, we, there we go. We would do 16,000. I'm sorry, give me 1 second. I'm thinking about multiple things at the same time. This plus 1. We have to do at the end of 18 months, I think they said. So that's the end of 18 months there. I want to do the rounding thing that they did as well. How much do you owe at the beginning of the 18th month? So this needs to be a rounded version into 2 decimal places, because that's kind of how we talk about money with cents. 1.0075 times the previous value minus 300, and doing this for 2 decimal places. So this is what's at the end of the first month, etc. And we're going to, or at the beginning, I guess. And then we'll go all the way to the 18th month there. Or, well, actually, they said at the beginning of the 18th month. So if this is the first, you may take out a loan. At the end of each month, you make a payment. So they said at the beginning of the 18th month. Okay, so the end of the 17th month, I believe, is the beginning of the 18th month here. So I think it's going to be this number, $12,749.33. So that's what I'm going to write. I think it's a little tricky because our loan thing was at the beginning of the, at the end of each month you make a payment. So, okay, I think I have it right, but I think I just need to shift my numbers up. I'm going to go back to this Google Chrome thing, and the 16,000, where am I going? Google Chrome. I'm sorry about this. For the 16,000, that is still the beginning of the first month for when I take out the loan. And then at the end of the month, I'm now at this stage. So I don't need this number here yet. So I think that's where we are. For N, we represent the beginning of each month. That's the beginning of the first month. Here's the beginning of the second month because the end of each month is the da-da-da like that. So I think we are still at that number. So A sub 18 in this case will be, and yeah, that is right, because I said my first term was 16,000. I need that still be 16,000. $12,749.33. Part C, how long will it take to pay off the loan? Okay, so for that one, we have to go back to the thingy, and then we have to figure out, now I don't know if it's at the end of this month versus at the beginning of that month, but we have to figure out basically when this hits negative territory. And I lost my Google Chrome. There it is. So let's copy and paste both of these a little bit. Let's see when it starts hitting negative land. We're way past. Oh, not way past. It's around that 70th. So at the beginning of the 69th month, we still owed this much. At the beginning of the 70th month, we owed this much. So I'd say is that after 69 months then? Because this is the beginning of the 70th month. So it takes 69 months to then pay off that final one. So I'm going to say 69 months for that one. It's kind of, I have trouble sometimes answering that the right way, and I feel like the more I say it, the more I might understand it myself, but the more I might confuse you guys. So I'm going to say 69 months for that one. Part D, if you pay $350 instead of $300 each month, how long will it take to pay off the loan? How much money will you save? Explain. So now I have to figure out, I don't know how to figure out how much money I'll save with that. I have to think about that. Let's keep these intact. Okay, keep those intact. And let's do, instead, a different one on this side. Oh, you can't see what I'm looking at. And let's do, that's the problem. I'm not looking at what you're looking at here. Let's do the same month thing over here. And then let's have a new, whoopsie. And then let's have a new algorithm thing going on. 16,000. Now, instead of doing this, we're going to do pay off $350 a month here. Let's figure out when this hits negative. How much money will you save? I think will be based off of looking back down and seeing the difference between these $2 amounts or maybe these $2 amounts. I got to figure out which one would be that difference there, because these are amounts that I'm not paying basically during that time. Maybe that's how you look at it. This one looks like it's going to take 57 months. So there's a whole year less because that's 12 months difference. So I think based off that, we would say it takes 57 months. So I'm going to say that 57 months. I got to figure out how this next part is answered. Sorry, I'm looking at my spreadsheet again. I got to figure out how the next part is answered for how much do I save. Here's the problem. I'm not in financing. I have no idea how that part works with it. So I'm paying a certain amount a month, but with that interest involved, let me think about this one. Okay, I'm not confident in my work on this, and I'm still not done. So here's what I'm doing so far. I had to research this a little bit, and I was trying to look up how the interest paid thing works. So when they're saying how much is saved, you got to take the difference between how much interest you had paid in one versus the other, which makes sense. You're not just paying the $350 a month. You're talking about the interest that you're paying. So what I did, and I'm not going to go deep into this thing overall because I'm going to screw it up, but I have these other columns for interest paid, and interest paid on these per month sets. This is for, remember, these are two different columns. This is the 350 set and this is the 300 set. For the interest paid, there's the 300 paid on top of what you have left, right? You're paying the $300 in the month. So you add 300 and subtract the difference with that set. So that's why I'm going to do this plus 300 minus the previous amount. So you keep doing that, and I did that until you get your final set, and I added those together. So adding the interest paid after this hits my negative, this goes from here to the negative, gets me to this number, $4,509.84 of interest paid. Now, as far as this negative number goes, I don't know if I got that one calculated right because you have to do something when it hits zero and because an overdraft and stuff. Maybe if I'm off by a couple cents, I'm going to leave it. I'm not getting that part. I'm having too much trouble as is. These ones here in that same light, this is paying $350 per month. So when you add $350 to how much you have left with that and subtract it from the difference of the previous set, you have $120, and this is your interest paid on a per month basis. And this is the sum of all those. I could have put the sum in the next column over, but I didn't. So this is the sum of all these ones. You can ignore this one here. The sum of all these ones is this guy here, $3,666.76. So how much money you save is you save the difference between these two amounts here. So 366676 equals 366676. So the difference between those two is $843.08. I don't know if that's exact or not. Probably a couple cents off when it comes to overdraft stuff, but it's probably somewhere near that amount based off how much you are paying in interest. Remember, it's the interest on top of the loan amount. So it's those totals, but since they're the same loan amount, I'm not caring about that part of the difference. It's just the difference in interest paid. So to me, that final result there is, I gotta go back. I have to look at the number again. $843.08. I'm just gonna put around $843 saved. There will be some error because the overdraft part, which I didn't quite get to, but that's going to be about it, I believe, based off the interest amounts there. It's tough. Listen, I don't know how to do that finance stuff. I'm limited in some of my knowledge, and that's part of it. Okay, someone else help me on that problem, please. Number 3. The table shows that the force F in pounds needed to loosen a certain bolt with a wrench depends on the length, L, in inches of the wrench's handle. Yeah, if you have more length on it, it's going to require less force. Write an equation that relates L and F, describe the relationship. Now, this might be, I forget what chapter, it might have been the previous one. This might be like, what do you call it? Inverse variation? inverse variation equation thing. So let's copy and paste that table, see what's going on there, and see if we can come up with, is there a constant of proportionality, basically. Hopefully there is, and then we can work that thing out. That hopefully one varies inversely with the other. So does L times F, do these multiply to the same things, basically? 6 times 1250 is 1500. I know that. This thing's also 1500. Let's see what 12 times 125 is. I'm going to guess 1500. 12 times 125. 1500, yep. And it just so must have to be, yeah, that's going to be 1500. So all these is some L times F scenario. So our constant of ratio, our constant of variation, I don't remember what letter they use. I'm familiar with K in the past. I don't know if they use K. I cannot remember. I'm going to use K. My constant of, they might use A or something like that. Sorry if I'm using the wrong letter. My constant of variation is L times F. Therefore, the force is inversely related with, it varies inversely with the length of the thing. So I can say F equals K over L, like so. Now that constant of variation is 1500. So 1500 over L. Is that all they wanted? Describe the relationship. They're inversely related. I'll just say it's an inverse variation relationship. Yeah, what was the letter they used for constant variation? Was it K? Ooh, I don't know. It's been a while. All right, number 4. Order the functions from least average rate of change to greatest average rate of change on the interval 1 to 4. Justify your answers. So the first one, f of x equals 4 times the square root of x plus 2. We have to figure out what f of 1 and f of 4 are. This is 4 root 3. And f of 4 is 4 root 6. So we have to figure out, it's basically their slopes. The slope of A, because this is all about A, the slope of A is going to be y2 minus y1 over 4 minus 1, x2 minus x1. So, I don't know. Let's see what that is. You can factor out a 4 if you wanted to. It's 4 times root 6 minus root 3 all over 3. Let's figure out what that is. I don't know what it is. Hold on. 4 times root 6 minus root 3 all over 3. The average rate of change here is around 0.9566. I don't know how close they're going to be to each other, so I'm going to give you a bunch of values there. For B, x and y vary inversely, and y equals 2 when x equals 5. So y equals 2 when x equals 5 when they vary inversely like this. So your constant of proportionality is 10. So your equation is y equals 10 over x. So we have to figure out the f of 1 and f of 4. So in this case, f of 1 is going to be 10 over 1, which is 10. F of 4 is 10 over 4, which is 5 over 2. So your slope here of B is going to be 5 over 2 is 2.5, by the way. So y2 minus y1 over, again, x2 minus x1. That's negative 7.5 over 3, which is negative 2.5. When they say order from least to greatest, I'm going to assume that negative numbers are smaller in that capacity, what we're talking about. I'm going to copy and paste this all the way to the other page because I hate when I run out of the binder paper room here. Give me 1 second. No, I copied and I waited for it to copy. Copy and wait. Let's wait a second, guys. Let's let this computer catch up on the clipboard and copy that, please. There we go. Much better. Okay, C. C is a graph. Let's just use the graph and calculate the slope. Here's the y when x is 1, and here's the y when x is 4. All right, we're going from 2 to 11. So f of 1 is 2, f of 4 is 11. That slope is a rise of 9 over a run of 3, which is 3. And then D, f of 1, based on the table, is negative 4, and f of 4 is 5. That's also a rise of 9, right? From negative 4 to 5, that's a rise of 9 over a run of 3, which is also 3. So B is the smallest because it's negative, and then A is a decimal that's less than 1, and these are a tie. I guess those are just a tie, literally. So I'll just order it BACD or BADC, whichever one you like to put. But that is the order. C and D are tied. Okay, I don't know what... I'm not remembering what chapter that would be from. I'm misplaced in my chapters now. Number 5. A running track is shaped like a rectangle with 2 semicircular ends as shown. The track is 8 lanes and are each 1.22 meters wide. I wonder if that's a fact. I'm going to assume so. It's not drawn to scale, though, but I'm going to copy and paste this over. The lanes are numbered from 1 to 8, starting from the inside lane. The distance from the center of a semicircle to the inside of a lane is called the curve radius of that lane. So the inside of the lane. The curve radius of lane 1 is 36.5 meters as shown in the figure. Okay, so one part they're not sort of indicating that hopefully you can make sense of in the problem is that there is a rectangle portion, basically, which is like the straight part of the track. And then these are the 2 semicircles they're talking about here and here. And again, that's the rectangular portion there. Maybe I can do dotted lines on that part so you can see the full rectangle aspect. I don't know what they're going to ask it. This might be a robust question. I said I hope this would be fast. I don't think it's going to be very fast. Is the sequence formed by the curve radii arithmetic, geometric, or neither? Explain. They should be arithmetic. Just the radii should be arithmetic. So the width is 1.22 meters from one to the other. They said this guy here is 36.5 meters. That includes right here. So 36.5. Then it's another 1.22, 1.22, 1.22, etc. to each one. So it should be arithmetic for part A for just the curve radius. So arithmetic common difference is 1.22 from one curve radius to the other, given that they are just a lane's width apart, even though the first term isn't 1.22. You add 1.22 to the next ones. Part B. Write a rule for the sequence formed by the curve radii. So that's where, again, the first one is 36.5 away, and then you're adding 1.22 each time, times that n minus 1 bit. So if I'm going to simplify that, it's plus 1.22n minus 1.22. 36.5 minus 1.22 is going to be 35.28, I think. 35.28, and that's going to be in meters for that. Part C, world records must be set on tracks that have a curve radius of at most 50 meters in the outside lane. Does this track... So first of all, before we answer this, I expected them to give a lot more robust, a lot different questions overall that could have been really scary for circumferences of all these things and all that. Oh my gosh, I'm kind of happy they're not doing all that. Anyway, does the track shown meet the requirement? Explain. What we need to know is what the outside lane... They said 8 lanes. The outside lane, A sub 8, we need to make sure that it is less than or equal to 50 meters. So we have to do 1.22 times 8 plus 35.28. Now, off the top of my head, I don't know. I think that's less, but I don't know exactly. It's 1.22 times 8 is around 9 something, 10 something. 1.22 times 8 is 9.76. So 35.28, 45.04. So A sub 8 is 45.04 meters, which is less than or equal to 50 meters. So yes. I'm not writing a full sentence, but Yes, because that's less than or equal to 50. I wonder why. Oh, I get it. If you had a track that was wider, then you're running straighter for longer, your curves are less sharp. So in that sense, they want you to, I guess they need something more standard in that way. Okay, number 6. Order the sums, that's this chapter, from least to greatest, justify your answer. The last one was kind of this chapter as well, because it was all about sequences. So there are a lot about this chapter, despite the cumulative assessment part. They just say, let's just have harder or weirder or different questions. All right, order the sums from least to greatest, justify your answer. Okay, let me copy and paste these over, and maybe I can number them from there, something like that.
Oh my gosh, excuse me.
Now, I kind of want to predict answers before I calculate them if I'm able to. I want to see if there's something within them that I can... Again, least to greatest, like the slopes, which I probably could have tried it with those ones in predictive format. I don't know if I would have gotten it right. For these ones, the smallest ones will be the ones that are negative. This will not have a negative sum. This won't. That won't. This will. All the terms are negative, so this will be a small one. That's positive, and that's positive. I believe from least to greatest, this would be number 1, the smallest. Now, this has an infinite number of terms, but starting from 60, you're taking a quarter of it each time. I imagine that's going to be pretty small. Compared to a quadratic that you add over and over that increases over time, I imagine that gets bigger, like 10 squared is 100, stuff like that. I'm guessing that would be bigger than this one. I'm guessing this would be bigger than that one as well. Oh, that one's just 10 point. Oh, that doesn't increase as much. This is either 2 and 3 or the other way around, and I don't know which. I'm just going to put those as in it's kind of one or the other is my guess. This should be the biggest one. Exponential functions beat quadratic ones all day. Not all the time. This is only 5 terms, but the 5th term is already in the thousands. I'm guessing this is the highest value, and I'm guessing a linear one is going to lose to a quadratic one. Despite the fact this is one more term than that one, I'm going to guess this is 4th and this is 5th. So I don't know about these two. It's kind of but my guess is it's going to go like that. Now, we got to evaluate these for sure, but it's nice to kind of look at those as well. So the first one, where we're going from 2 to 10 of k squared minus 2. Now, there are a couple things with this that if you don't want to add these up, like if you want to use a formula, what I might do here is you can separate this to this and then minus basically these, k equals 2 to 10 of 2, which looks really weird, but from 2 to 10 is actually 9 terms. It's not 8 because 2 counts as one of your things. So this is actually doing minus 2 times 9 in that way. Now this one here, k squared from 2 to 10, it takes that formula of that n times n plus 1 all divided by 2, but we do have to subtract 1 because because 1 squared isn't in here. So we do have to subtract 1 from that result. Will that change the final outcome of how it compares in size to others? Probably not. So 10 over 2 is 5. 5 times 11 is 55. And 55 minus 18 minus 1 minus 19 is 36, I believe. So that number should be, I don't know if I did that right. That number should be 36. The next one, I don't know if that's right. That sounds really wrong. Oh, k squared. Oh, no. Time out. I'm like, that seems really low because I'm adding 100 and stuff like that. This k squared, I'm sorry, it's n times n plus 1 times 2n plus 1 all over 6. Okay, there we go. Let's do that again. So 10 over 6 is 5/3. 21 over 3 is 7. 5 times 7 is 35 times 11 is 385. There we go. 385 minus 19. And that's going to be 366. Oh, it's like 36, but with another 6 added. I should have known that. There we go. That seems a little bit bigger. I was going to say, I think the linear one's going to beat it. Oh, well. Okay, I got it. All right, next one. We have from the 1st to 10th term. You know what? It probably would have been faster for me to do my just the simple version, but I want to use the formulas. Unfortunately, I used the wrong one. I wasn't thinking in my head about what we had. Quadratics, not linear. All right, this one is an arithmetic series from the 1st to 10th term. We are going to be doing the sum of the first 10 terms times the first term. Sorry, we're going to pair off the 10 terms times the first term, 5 times 1 plus 8, plus 5 times 10 plus 8. A sub n over 2 times a sub 1 plus a sub n, which is 5 times 71. Oh, this is close. That's 355, right? 355? That was close to that one. I imagined this one would have been significantly bigger. I know that this had a 5 in front of it, but I thought that still would have trounced it. So it didn't trounce it by much, if I calculated that one right. The next one, and I don't know what this amounts to, I just feel that these are like, second and third, this one and that other one. So let's go from 1 to infinity, 21 over 2, which is 10.5, over 7/8 to the k minus 1 power. Now your first term is 21 over 2. Then we're going to do 1 minus 7/8. Because that number is less than 1, we can use this infinite series sum. So we're going to take 21 over 2. 1 minus 7/8 is 1/8. Divided by 1/8 is multiplied by 8. 8 over 2 is 4. 21 times 4 is 84. The next one should be the smallest because it's negative. So I no doubt this one's the smallest. I just don't know what the value is. Okay. The first term is negative 8. The common ratio is 1/2 to the 12th power over 1 minus 1/2. 1 minus 1/2 is a half. Negative 8 over 1/2 is negative 8 times 2, which is negative 16. So this will be negative 16 times 1 minus 1 over 2, I think 4,096. I'm going to use my calculator on something here in a second. Negative 16 times 4,095 over 4,096. This is just going to be a weird number, I guess. Okay, so that should be... negative 16 times 4,095 over... Negative 15.99609,375. I'm just going to round that up to around negative 16. I mean, look, clearly it's right around negative 16, right? It's whatever. Okay, it's not exactly negative 16. Maybe that's what it converges to. So I'm just going to write negative 15.99 just so I'm not stating it's actually negative 16. But it's still the smallest value. It's the only one that's negative. So far everything's in line. What I have to figure out is whether this one is smaller or bigger than that 21 over 2 value. This is also an infinite set. How long's the video gone? Oh, I'm past the hour. 0.25 is also less than 1. So the first term over 1 minus that common ratio, that's 60 over, listen, 0.25 is a quarter, 1 minus a quarter is 3/4. We're dividing by 3/4, which is multiplying by 4/3. 60 over 3 is 20. 20 times 4 is 80. How does 80 compare to that other number? It's smaller. It's smaller than 84. So far, what did I put? I put it as smaller. It's not by much, but I did put it as smaller. The last one should be the biggest is my guess because we're adding big numbers. They don't start big, but they get big. So once again, geometric series. First term is 2. Common ratio is 4. Raising the 5th power, so that's big, over 1 minus 4. So this is 2 over negative 3, and then times 1 minus, I believe that's 1,024. 1024, which is 2 times negative 1023 over negative 3, which becomes a positive number. 1023 over 3. I don't know. 341 and times 2 is 682. So 682 is that sum. All right, so what are our rankings here? This is the biggest, I believe. 682, yes. So we have, this was the smallest because it was negative. And then this guy was smaller than that guy. They were smaller than the 355 and 366, right? Which one is 355? Was it this? Where's 4? Was it this guy? 5i. That was 355. This was 366, and that was okay. So this is the official answer order that I have right there. So what I predicted was right. I didn't know whether these would be it, and I screwed up calculating this one to begin with, actually, which sucked. Okay, number 7. The diagram shows the bounce heights of a basketball and a baseball dropped from a height of 10 feet. On each bounce, the basketball bounces to 36% of its previous height, and the baseball bounces to 30% of its previous height. About how much greater is the total distance traveled by the basketball than the total distance traveled by the baseball? Okay, this gets tricky because, okay, first of all, these are infinite series. At some point, these things come to a rest, but that's how we get that microscopically small when it comes to bounces, what it's converging toward. That's fine. We can still use the series for that. The tricky part is the idea that the total distance is how much it goes up as well as how much it goes down. So whenever we do a series, when I'm talking about the basketball, if I did this series here, an infinite series from the first term to the infinite term of 10 is the amount that it drops the first time, and then it goes down 36% of its previous bit like that, this only gets the downward drops. That's just 10, and then 3.6, and then about 1.3. I'm looking at the numbers on the screen. 10, 3.6, 1.3. It doesn't account the amounts that it goes upward. So what I could do is this. I could take this sum, this infinite series sum, but I also need to double it because it goes up as many times it goes down, except for the first drop. So I need to double this amount. The only thing is it also is doubling the 10. It only goes down 10 once. It doesn't come up 10. So I do need to subtract 10 just once from the overall. I need to count the time it goes down. But when I doubled it, it went up. So I need to take away the time that it goes up because it never goes up that amount. So this should be the basketball's computation for this. That means this will be, this is in my head on how this would work. This is 2 times the infinite sum, which is the first term over 1 minus the common ratio, and then minus 10. 2 times 10 is 20. This is over 0.64, then minus 10. I'll let the calculator do the rest. 20 divided by 0.64 minus 10 is 21.25. So it's going to travel a total of 21.25 feet overall. It does the 10 plus 3.6 plus 3.6 plus 1.3 plus 1.3. 17.2. I guess, yeah, I guess that makes sense to me. No matter what number I got, I might say I guess it makes sense to me. But at least more than 20. That was more than 20. Now the baseball, because what's the question? What's the difference? How much greater is the distance by the basketball? So we got to subtract this one from the baseballs as well. Now the baseball should be the same exact thing. One difference, 0.3 instead of 0.36. So we're going to go 1 to infinity of drop 10 feet, rebound ratio of 30%, and then minus 10. Because it also drops from 10 feet there. So same exact stuff. Basically, it's going to be 20 over 0.7 minus 10 instead of 20 over 0.64 minus 10, which actually will be a smaller value. So 20 over 0.7 minus 10 is around, this one's rounded, this has some decimal, long decimal work, 18.57 feet. So 21.25 minus 18.57 is around 2.678. I'll say around 2.68 feet. I don't know what answers are up there. I hope I got it right. Let's see. Give me 1 second. I'll first box that. I'm confident is 2.68 on there. There it is. C. All right. So C, around 2.68 feet. Okay. The final question, number 8. All of these, for a cumulative assessment, a lot of these ones are from this last chapter, which is fine. It's just, they kind of should do one for like chapter 1, chapter 2, things like that. Although I couldn't name what some of the other chapters they were from. Number 8, a semicircle with a diameter. Okay, this is not from this chapter. This is, I think, from chapter 1. A semicircle with a diameter of 1.5 units is rotated around its diameter. What is the volume of the solid of revolution that is formed? So we have a semicircle. Just think Patrick's dome. A semicircle with a diameter of 1.5 units. It's rotated around its diameter. So you're doing the rotation around here. You're making a sphere. You're making a sphere. Sphere. What is the volume of the solid of revolution that is formed? So a sphere's volume is 4/3 pi r cubed. Our diameter is 1.5, so our radius is half of 1.5, which is 0.75. So the volume of this is 4/3 pi times 0.75 cubed. You know, I like multiple choice as much as anybody because I can tell that it's not going to be in terms of pi, so I get to use pi in my answer. So I'm going to go straight to the calculator from here. So in my calculator, I'm going to do 4/3 times pi times 0.75 cubed. 1.767 is around 1.77, and that's on there. Around 1.77 cubic units. That answer is A. And that is what I'm going with. Whew. All right, guys. That'll do it for this one. This is Mr. Robinson. Thanks so much for watching. Listen, in some bizarre way, I'm feeling less confident in my math than more so. It's almost one of those things. It's like if you play video games. I don't play RPGs so much or anything like that, but like platformers, your skill level stuff goes up, but the bosses also get harder at the same time. So it's not like it's getting easier just because you got more power-ups, stuff like that. You're facing tougher competition. I think that's what's happening. They're asking tougher questions along the way, even if I don't know if I'm learning more math along the way necessarily, but I think they're just making it harder for me as I go. So hopefully everything I'm doing is a little bit alleviating for you guys. Those finance questions, guys, I'm not good at finance. I'm not. So hopefully my struggle through it was so real that it made sense to you in my process. I know I confuse myself sometimes in the process as well. That if they ask me the same kinds of questions later, I might have trouble. Go Braves, by the way. Thank you so much, guys. Take care. I'm going to see you when we hit trig.